To my YouTube channel. This is LiQWYD Academy. This is my first video of the year, and I thank you for joining me in this video lesson. In this video lesson, I will be solving simultaneous linear and quadratic equations. I have 3 examples I'm going to do to show how to solve these equations simultaneously. Before I get started, please, I would like you to subscribe if you have not done so, and click on the notification bell to get notified when I do subsequent videos. So the topic once again is simultaneous linear and quadratic equations. And to start with, I'll give you some definition. The definition of a linear equation. A linear equation is a polynomial of the first degree. It is an equation in which the highest power of the unknown is 1. Example is x minus 6 equals to 5y. As you can see, x is raised to power 1, though we don't write the 1, and y is also raised to power 1. So definitely this is a linear equation, one in which the highest power of the unknown, either x, either y, either a or b, is 1. Let's see a quadratic equation now. A quadratic equation is a polynomial of the second degree. It is an equation in which the highest power of the unknown is 2. For example, we have here x squared minus 6 equals to 5y. The difference between the last one there and this is that this is having a 2, is raised to power 2 here, and y is raised to power 1. So this makes this a quadratic equation because x is raised to power 2. So that's basically the difference between linear equation and quadratic equation. So in this lesson, we are going to be solving about 2 or 3 examples to show how we solve them simultaneously. Let's get into the examples. The first one here is solve the equation 3x plus y equals to 10 and 2x squared plus y squared equals to 19. When we see solve the equation in mathematics, it means that there is an unknown that needs to be found, and the unknown here is x and y. Now it's impossible to find 2 unknowns in a single given one equation, but it is possible when we have 2 different equations. So here the first one, 3x plus y equals to 10, is a linear equation, while 2x squared plus y squared equals to 19 is a quadratic equation. So let's get started. We have 3x plus 3x plus y equals to 10. I'll call that my equation 1. Then I have 2x squared plus y squared equals to 19. I'll call that my equation 2. So from equation 1, I'm going to get my equation 3, and I'm going to make y the subject because the coefficient of y here is 1. So I find this convenient rather than using x for my equation 3. So I will say from equation 1, I have y equals to 10 minus 3x. I'll call that my equation 3 now. That's my equation 3. What I just did is to take 3x to the other side. Now, what I'll do next is to substitute. I'll substitute equation 3 into equation 2. what I did was to use equation 1 to get equation 3, and I'll put it back into equation 2. So I will have 2x squared plus y square. Y now is 10 minus 3x. So I'll open a bracket. I have 10 minus 3x. I put my square equals to 19. So I'll proceed. I'll have 2x squared plus, I would like to use a big bracket, a square bracket now. I have 10 minus 3x. I'll close the bracket at 10 minus 3x, then equals to 19. So I will expand this. We have 2x squared plus, I'll still use the big bracket. I have 10 into bracket 10 x. I close it. I have minus 3x, 10 minus 3x equals to 19. So I will go. I have 2x squared plus, I want to deal with the bracket first. 100 minus 30x minus 30x plus 9x equals to 19. So I'll move on. I can see this to be the same. So I will have 2x squared plus 100. I'm trying to open the big bracket now. Plus 100. This 2 will give me minus 60x. So I'm going to write that minus 60x plus 9x squared. I made a mistake here. 3x times 3x will give me 3x squared. So I put that here now, equals to 19. So I'll move on. I will have 2x squared plus, I'm trying to collect like times here, 2x squared plus 9x squared minus 60x equals to 19 minus 100. Or rather, I can bring 19 in between the to the left hand side. I can bring 19 here, so I will have that to be plus 100 minus 19. Then nothing will be left on the right hand side, 0. So I will have 2x squared. I write that properly. 2x squared. Sorry, that will be 11 rather. 2x squared plus 9x squared will be 11x squared minus 60x. 60 asks no partner. 60x plus 81. That's 100 minus 19 equals to 0. So this is a full quadratic equation. A full quadratic equation. So I'm going to factorize. That's the method I will use here. I'll factorize this equation. If only I can write factorize properly. Okay, I got that. So I'll factorize, and you know I will factorize this. 11x squared minus 60x plus 81 equals to 0. So I'll bring these two. I'll bring these two out. I bring these two, 11x and 81. When I multiply them, I have 11 times 81. That will give me 11. That will give me 88, and I have 198. So I have 891. Now I'm going to look for the factors of 891 that we add or we'll subtract to get minus 60 here. So I will need my calculator here. Calculator now. Okay, so I have 891 divided by 2. That will not work. 891 is not an even number. I can try 3. When I try 3, I will have 297. I don't need a, okay, it will not still work. 30, I can try 31. 31 will give me 28.7. I need a 2 digits, so 32 will not, yes, 33 will give me that's 33 and 27. So that's exactly what I'll use. I'll have 11x squared minus, anyone can come first. I'm using 27 and 33 because both of them will multiply and give 891, and when I subtract, when I do minus 27 minus 33, it will give me minus 60 that I have here. So I will have minus 27x minus 33x plus 81 equals to 0. So I'm good now. I have 11x, sorry, at this juncture I'm going to factorize. I'm going to look for what is common between these two, and as we can see, I only have x to be common, so I bring x out. That's 11x minus 27 minus anything that is here is where I'll bring minus. What is common here? 3 is common. It's 9 common. No, 9 is not common. So I will have 3. Yes, 3. So I have 11x. I'll write that properly. So minus 27 equals to 0. I'm very sure because what is in here is what is in here, so I'm good. So I'm almost there now. So I will have x minus 3 equals to 0, and that will be x equals to 0 plus 3. That makes x to be equals to 3. So that's the first value of x. Then I go on, I have 11x minus 27 equals to 0. I have 11x equals to 27. I took 27 to the other side, it changes to plus. So I divide both sides by 11. I have x equals to 27 over 11. I can put this to be 2 whole number. How many 11 can I get in 27? 2. 2 whole number 5 over 11. So I have two values of x simply because x we have a quadratic equation here. So what is next is to find y, and we are also going to have two values of y because we have two values of x. So let me get to the next page. I have a blank space here. Okay, so I have x to be 3. I have x also to be 2 whole number 5 over 11. Now if I go back to equation 3. Equation 3 is y equals to 10 minus 3x. Since I'm looking for I need to find y now, I think it's good for me to use equation 3 rather than using equation 1 or 2. So I will have from from equation 3, which is y equals to 10 minus 3x, I will have y equals to 10. I'm doing this first, minus 3 into bracket 3. So that's y equals to 10 minus 9, and y equals to 1. So that's for x equals to 3. Then for x equals to 2 number 5 over 11, I have y equals to 10 minus 3x. I have y equals to 10 minus 3 into bracket. This will give me an improper fraction. This will give me 27. 11 times 2, 22 plus 5, 27. 27 over 11. I think we got that the other time. So we have y equals to 10 minus 3 times 27 will give us 81 over 11. So how do I work this out? I can find LCM, knowing that this is over 1. So I have 11 here. LCM of 1 and 11 is 11. So okay, so I will have 1 in 11, that's 11. 11 times 100 times 10 will give us 110, minus 11 in 11 will give us 1. 1 times 81 give us 81. So 110 minus 81 will give me 9. This should be 0. I borrow 1, 10. This should be 29. So y equals to 29 over 11, and that will give me 2 whole number. Yes, 2 whole number, 7 over 11. As in 11 in 29 will be 2, remaining 7. So I've gotten my answer now. My answer is unique, is x equals to 3 and y equals to 1, and also x equals to 2 whole number 5 over 11, and y equals to 2 whole number 7 over 11. In some other cases you can write it this way. It will still be correct because this is x, this is y, and I write this one also 2 number 5 over 11, comma 2 number 7 over 11. So these two are the solution of the equation that was given to us, 3x. When we put those values in here, we are going to get this. When we put them in, we are going to get this. I hope you enjoyed this example. I'm going to do 2 more in the next video.